All right, so now that we have some general idea of what priority queues are and what they're used for, let's try to define them in a way that we can actually have some hope of implementing them. So we're going to have two primary methods here. We have insert and del max. Okay, these are the only two things that priority queues are really obligated to provide. The first is called insert, right? So insert basically has the task of I want to add something new to my collection. And usually it's something very simple, right? It could be something like literally, insert of, the number 5. I don't have any other parameters, I don't have anything else to worry about. It's just a way for me to take an element and throw it into a collection. One little note here, right, and this is something to keep in mind, is that whatever I do the insert on, that must be something that is orderable, right? I can't just throw in arbitrary things, right? I need to throw in things that have some sort of order, like numbers or letters. Because if they don't have an order, well, I'm not going to be able to basically reach in there and pull out the biggest one, right? It doesn't make any sense. How can I say, give me the biggest if the things in the bag, things in the queue, don't have any sense of greater or smaller, right? So whatever is going into here, right, must be some sort of a comparable, right? To use Java terminology for a second. Conceptually, right, you just want to know that they have some sort of order on them, right? Java, comparable type. All right, next one we have is a del max. So del max kind of does two things, right? Del max, right, maybe we could call it by saying it looks something like, x equal del max. Basically what it's doing, right, is going to look in your collection, right, your queue, and it's going to get out, the largest thing here, right? We could do either the largest or we could do the smallest, right? Basically, we're going to pick, one or the other. For us, in the examples will work, we'll stick with max, right? So we're only going to get out the biggest thing every time we call this. And this function basically does two things. First of all, right, is it removes an element, right? So it looks at this queue, takes out the element that's largest, right? Removes it completely, right? Sort of like a pop, if you think about a stack. And then that element, it returns it, right? And so here, right, we'd basically be taking out something and then storing it into X. So two operations there, right? Remove and return. Again, kind of like the pop operation in a stack, kind of like a dequeue in a queue. All right, so this is kind of our language that we use to talk about priority queues, right? So we'll have an insert and a del max, right? These are the two things we want to implement. Now, when we go to implement this, and we'll talk about this more in a second, right? We're gonna basically be aided, right, when we try to implement this by the fact that we don't have to do a ton of work, right? If I think about sorting a list, right, then I have to worry about this, right? So I need to have all this stuff here, basically in order, right? It's 1 through 7, right? Everything's perfect. But notice if we look at just these operations that a priority queue is obligated to support, well, we don't really need all of that, right? All we need is this over here, right? We need the largest element, and we don't really care about anything else, right? This is all, I have my little question mark here, right? Because it's like, well, I don't know what's there. I don't really care what's there, right? All I know is that at any particular moment in time, I'm going to be obligated to take out the biggest thing, right? So this discussion here, right, somehow is leading to this idea of data structures, right? So the question is, how do we structure our data, right? How do we structure our data in a way that enables us to develop our ADT to be something that we can quickly implement? Okay, so that's going to aid us later on, right? So just keep this in mind, right? This functionality only requires this one thing, right? This 8 over here, right? We only need to see the large thing. That's the only thing that's going to be required. All right, so conceptually, this is what a priority queue is.